Hello, welcome, and an excellent evening. And today I want to revisit an older program that we did, and I'll try to link to the previous episode. And that was the fixed arithmetic 3D rotating cube, which doesn't use any floating point. That's why it's fixed arithmetic, and looks quite decent, I think. And a while ago I saw an interesting demo effect where I thought, wow, this is pretty simple, but looks quite intriguing and has some interesting properties. So let's do that, I thought. And that's what this project here is, and it's based off of the same thing that we just saw, but we'll heavily change it basically. First of all, I created two include files for the geometry instead of having these arrays, these static arrays here in the draw cube function, and that contains the vertices and the edges of the 3D geometry. And we'll have two different ones. One I call pyramid. Actually, it's a little bit of a different thing actually. Two pyramids stuck together, and something called cube.h, which is just the cube. And we need a constant because this is very old C code, and we can't use a const int or something for the size of the arrays, and at most we can have 64 vertices. We don't even use that much, but either way that should be fine. Then we're going to start and clean up this function. A lot of stuff will be kicked out basically. First of all, we will have, instead of the geometry, we'll have pointers to the geometry. Pointers to the vertices in X, Y, and Z direction. That's pretty important. Also, we will have pointers to the edges, which is basically connections between the things, the vertices. And then we have a size t, which tells us how many vertices are in, or how many vertex coordinates are in there, and how many edge coordinates are in these arrays. And this is actually all within the file here. There is something like pyramid vertices 12 and pyramid edges 40 and this stuff. And I will show you how to get these coordinates actually using Blender, so you can model your own simple geometry in a bit, or well, let's just do it right now. This is the object that I modeled because it looks interesting, and this is the code. I took inspiration from a Stack Overflow answer how to access the object data in Blender, and I will put this also into the GitHub or into the Codeberg repository, in the Git repository. And it basically creates a file /temp/object.h with these arrays pre-populated, and you can just move it to a different name and include that into your file to get different geometry. It must not have more than 64 vertices, obviously, or edges. Otherwise we'll have a problem. And to be fair, complex geometry for this effect looks not great anyway, so it must be very simple. All right. Oh, I didn't want to open this. I wanted to open the main program. So that's that. Then we need to adjust this because we don't have 8, but these max vertex size arrays for the rotated coordinates. I won't rename them now because that will take a long time. So it will still be called cube, rod x, etc. These are the rotated coordinates. You can check that out in the previous video, how this is being done. And the projected coordinates, that's the same. We need to have more than 8 for the pyramid. And I think that is more or less it. I think I adjusted the scale factor here, or this moving into the z-axis a little bit, but that is fine. Also, the new function will take a type, the type of object, which is just 0 or 1, depending on if you want the pyramid or the other. So we will put in a little switch statement here for the type. And case 0 is that we want the cube. Let's do it like this. So we save the cube coordinate array into the geometry pointers, and this is pretty straightforward. This is just taking the address of the cube geometry array and putting it into the pointer. And the same goes for the edges. And we need the number of vertices, which is called cube vertex. Oops. And number of edges. And this is called num edge equals cube edge. So that's that. Then break. And every other case we will default to the pyramid. You could put in more geometries here and switch, and that's maybe an interesting thing to do to see how it will look. Vertex y equals pyramid y, and vertex z equals pyramid z. Same goes for, let's just copy this. This is too tedious. But we must rename this here. Pyramid edges. Maybe I should have used a struct here. That would probably be better. That's also something you could refactor. Put everything into a struct, and then you just have a pointer to the struct, and it's all called XYZ, edges, vertices, and or number vertices, number edges. Something like that. I think that would be better. Also, we are not doing only 8 transformations here, but number of vertices. The rest, I think, stays the same. But I also thought that it might be nice to have not only a fixed distance from the screen center, but to vary this with a cosine or sine, it doesn't matter, modulo the time. So basically we will zoom in and out of the object in a nice smooth fashion. But now I think we're done. Also, we won't be doing a proper draw line, but we will use an XOR operation, and that will be quite interesting. Which means in the VGA.h is now a prototype for a drawline XOR function, and we will need a set pixel routine which can do an XOR operation actually. And we will do this very simply. The processor will do this instead of just taking the color that we have here, we will XOR the color or XOR the color with whatever's already on screen. And you can do this with this operator, which is basically the same as, for example, plus equals, which is basically A equals, let's say like this, let's put it here, A equals A plus B is the same as A plus equals B, and the same goes for A equals A XOR B can be written as A XOR equals B. So that's why we do it like that. And this is our set pixel XOR. And let's also implement this very quickly. This is very simple. Since we don't have templates or anything like that, we could use probably a function pointer, but that's a whole nother level of indirection, so it's much faster if we just copy the whole thing. Much more efficient for this old compiler. And then we just call setpix XOR basically. And that's already everything we need to do there. This function now is more or less complete. Down here we are already doing everything that we want, and we can have a little look if this already compiles. No, there's a bunch of warnings. Yes, okay, I think I mistyped something here or forgot something up here. Which was it? Okay, yeah, it has to be edges. And I've got a bunch of warnings, which is good because we should be using that. Oh, this is also still a mistake. We don't have this, but num edge it should be, obviously, because we now have not a fixed set of edges, but depending on the object. What else? Oh yes, right now we're still using the cube, X, etc., but this needs to be vertex and so on. Very quickly changing that, otherwise we will always have the same object, and we want to be able to switch the object via keyboard. We'll do that in a second. But this should almost be... Okay, yeah, this is something that we'll do in a second. Okay, here it is already. It looks still a bit weird and we can't switch anything. But you can see that this already looks interesting, but it's not the final thing that I want to show you. But it gives a hint at what we are doing. First of all, let's try and make us able to switch around the object actually. So when we get the key press, we will do a little switch statement here with the key code, and we will have a case something like 1 with a break, and I will copy this a couple of times. With the keys 1 and 2 I will switch between the two objects, and with keys Q and W I will start and stop the animation, because that will become very important in a minute. If we type 1, we want the type to be 0, and we will give the type to the draw cube function so we can switch between the two different geometries. This is just for fun. That doesn't have anything to do with the actual effect basically. And dt equals 0. So pressing Q will stop the animation because dt is our delta t, and we draw only if delta t is not 0. If the animation is stopped, we won't do anything, and otherwise dt equals 1 if we press W. We should put in a default statement. Every other key press is just simply ignored, so we're not doing anything. And that's that. Let's see if that works. Yeah, I still have one thing left here, and we can already switch between the two geometries. Here you see the second geometry being used. And it's interesting how it wipes away the previous iterations. That's the power of the XOR actually, and that's pretty neat. And we can switch back to the cube. And you see already that the 3D object looks quite interesting and quite weird in a way. But yeah, let's do something more interesting. Let's call the randomize function, which initializes the random number generator. It is, I think, maybe in the standard library. No, not, but it is. Oh, it is in the standard library, but it isn't listed per se. I think it's not an ANSI function. I think srand might be. But the randomize function uses the timer, so you get a different result every time you run the program, which is nice. So we randomize this, and now we will fill the screen with totally random numbers. This is the dword I variable that the compiler was complaining about. actually. So we will compare to screen height times screen width, because we need to write a lot of stuff here. And what are we doing? We are basically just setting with the buffer. We could also use, could have used setpics, but we're just doing like this. We put a random value in there. We take the modulo 2, because this will give us either a 0 or a 1. Modulo 2 does that. And we will multiply this by 15, because that will give us black and white. Very simple. And what happens if we do this now? Now the program is actually already complete. And as you can see, there's a lot of noise, and you can see the cube. The cube is there, but let me stop the animation. The cube is gone. You can do the same actually with the YouTube video. You can go back, and I will restart the animation and stop at any time. And I think I did something slower now, but it doesn't matter. We can also switch to the other geometry and stop this. It will disappear. Every time you stop the video, the thing will disappear, because this thing is only there due to basically two things. The flicker that we get from the slow movement, but we can, actually I was using dt equals 2, so let's do this here as well. One thing is the flicker basically that you have that makes it visible, and nothing else is actually there. You're just seeing the change between black and white pixels, and your brain forms the image from that. And that's why if you stop this thing, the whole thing disappears. And I saw that, I think in some demo or at the revision, I don't know anymore. And I found this very simple yet quite fascinating, because it's kind of like a little bit of an optical illusion. And at the same time, of course, it is not quite an optical illusion, because during the animation there is, like, due to the flicker, an intermediate value, a gray or something, plus your brain also interprets the movement and makes that more visible. We could probably make this go even faster. Let's try this by maybe we can actually do it like so. We can do dt minus minus and dt plus plus, and something like if dt, what is dt? Is dt signed? Dt is maybe unknown. Let's do it. I'm not sure if char is signed. Let's do it like this. If dt greater than 0, then we decrement it. And here a similar thing, if dt is smaller than, let's say, 126, because it will be plenty fast, and we are safe with signed chars then. Okay, this looks like so. And what happens if we make this faster? Can I make it go faster? Can I make it stop? Oh no, I have to press it like this. Oh yeah, that's way too fast. Okay, that doesn't really happen. Okay. No, that actually doesn't work quite well, because something exploded. And the actually the, yeah, this is way too fast. Okay, this is super fast. Interesting. Yeah, this doesn't work as expected. Let's do it a bit simpler. Let's revert and actually make this 4, just like that. Once we stopped and then redo it, it's faster. Now the gray is not as visible, but you still have the movement basically of the swapping pixels, and your brain will interpolate that. I hope this makes sense in some way. But what I love is that everything disappears once you stop the video, and that's pretty neat. That was already what I wanted to show you. A very nice little effect that I think is quite interesting. I think this could be still improved upon and made more interesting, but I already like it because if you were to stop this and ask, isn't there an object here? People will say, no, that's just noise. And you say, yeah, there's one, but it's stopped moving and it's invisible. So yeah, thank you. Next time I will hopefully have something more complicated again, but I thought this was a neat little intermediate episode. So thank you for watching, and see you in the next video.